So let's talk about the volume and surface area of prisms. In the previous video, we talked about the volume and surface area of cylinders, and this time we're going to talk about prisms, right? So prisms are actually figures like these, similar to cylinders, with one small difference that the base is not a circle but a triangle, and you need to make sure that the radius, oh sorry, in this case not the radius but the dimension of the triangle there, that stays constant. I mean, the bottom of the triangle, bottom of this prism does not have a greater triangle than the top, and the all those the triangles that are present in between this prism figure, they should always be you know having these constant dimension. It should be a regular figure. What I mean to say is that, right? So in this case, of course, we're going to use the same technique to derive the formula for volume, like the one we used to derive the formula for a cylinder, the base area into the height, right? So for any regular figure, it's always the same formula. In this case, the base area is this, whatever the base area of the triangle is at the bottom, and we know from the concept of dimensions that, and we just can we can stack infinitely many triangles of similar shape on one another and get a prism like this. So this height factor is going to give us how many of them we stack, and the base area into that height will give us the three-dimensional volume of that figure. So I'm not particularly writing the exact formula, because the formula for triangle, they exist in various different shapes. For example, the formula for a triangle like this would be like this: 1 over 2 base into height. And the formula for a triangle like this would be again 1 over 2 base into height. This time the base is the whole figure, whole length of this side, and height is this. But the triangles could actually exist in many other forms as well, like irregular shapes like this. So in order to calculate the area for triangles like these, where you are particularly given an angle here and a side length A here and a side length B here, the formula could actually be 1 over 2 AB sine of this angle theta in between, right? So we will learn how we actually calculate or derive the formula for a triangle which is not that regular like this. So we'll be actually discussing formulas of triangles in other videos. But the fact is, the point that you need to know is that for any regular figure, you just need to have the base area, whether it is a right angle triangle or a equilateral triangle or any other type of triangle. It depends. You can use a formula that is there for that particular triangle, and then you just need to multiply the height of that figure in order to get the volume. How do we calculate the surface area? Pretty simple. Surface area for a prism is the sum of the areas of all the sides, right? So it has this side and this side, so two sides, and we can just multiply the base area with 2. And the base area could be it depends upon what type of triangle it is. If it is a triangle like this where you're given an angle and two of the sides of the angle, you're going to use this formula. If it's a simple triangle, then you can use 1 over 2 base into height. In this case, remember, this h and this h is not same. This h I can write as capital H, right? Uh, base, this is area, base area. So what I'm trying to uh, say is that this h of the height of the triangle is actually this length h, right? This small length h, the height of the triangle, and this height is of prism, the capital H. So you need to be sure that you don't mess this up. So this is the base area into the capital H, the height of the prism will give you the volume. In this case, twice the base area, and then there are three sides of this prism, this side and then the two at the back. So there are total three sides, and you can simply find out the area of all these. These are three rectangles. So this this is a rectangle, and then there are three rectangles. Depending upon what type of triangle it is, you just need to know this length and you just need to know the height. You just need to multiply them together in order to get the these plus 3 rectangle areas. I'm just going to write it generally here. It depends upon what is this length and then what is this length. You don't have to generalize a formula. You don't have to, particularly write various formulas for different types of prisms. You can just simply, for a regular prism, it just has to be this, which has an equilateral triangle at the base. You just need to write the length of this side, which you can, for example, call x, and then h would give you the area of this rectangle. So instead of writing anything else, you just write the xh for an equilateral triangle. But it can vary, depends upon various type of prisms, right? So for a regular prism, it's just this. So I hope it makes sense.